Hello and welcome to my channel. In this video I would like to show you how to use the hierarchy of classes in MATLAB and the polymorphism, I mean the dynamic overloading of the functions, to make our code flexible and able to reflect the situations and relations we deal in real life. Okay, so imagine you have a company and in the company you have employees. Okay. And the employee is an abstract concept. What I mean? I mean that you may have engineers or drivers or administration workers, and all of them are the employees, but they are also instances of a real class, which is the driver or the engineer or the administration worker. So the employee is the abstract concept, and it will be reflected in our code as an abstract class. Okay, so we need to keep some informations about each employee, and we need to have some procedures which are for each employee, but they are different, and the difference is about the subclass, I mean real class, which the employee is a member of. I mean, for example, if we have, for example, the procedure to compute the salary supplement, it can be computed differently for an engineer and in a other way for a driver or administration worker, for example, but still it's the same thing to do. I mean, computing the salary supplement. For this reason, we may define this function in an abstract class as a procedure for each employee, and then define it differently in a subclasses, differently for an administration worker and differently for an engineer, for example. So this is what I would like to show you, how to reflect such a situation in a code in a flexible way using dynamic overloading. And as a bonus, I will also show you how to use a structure to make the code even more flexible. Okay, so let's get started with it. So let me create our abstract class. It will be very simple definition. Okay. That's a comment, very useful thing. Okay. The keyword class def, then the attribute abstract. Okay, and after the attribute, the name of the class, employee. Okay, so the class definition will be very simple, only a few properties. Those are fields at which we will keep the information about our employee. So it will be name, for example, the surname, sorry, the typing mistake, basic salary, and for example the year of experience. Okay. Then we have another block, I mean the private property, which we include just to show you how to deal with it. Okay, so private properties, then the attribute private, set access to private. Okay, and here I will include the structure with the professions for our employee and the positions. Then I will use it for computing the salary supplement to show you how it can be used, this structure. Okay, it will be clear soon. So I create a structure which I, for example, call the eng for engineer multiplier. Okay, struct, and then in this structure I will create the three fields connected with the field of specialization for each engineer. Okay, so it can be, for example, IT engineer, and the multiplier for the salary supplement, it will be, for example, 3%. So okay, and then we have, for example, civil engineering. Okay, and it will be, for example, 1%, and for example the electrical engineer and let it be 2%. Okay, so those are the multipliers which will be used for computing the salary supplement. Nice. And then, for example, we have also the position tab. So not only we will consider not only the field of specialization, but also the position at which the particular employee is currently on. Okay. Struct, and similar thing, three positions. So that's all what I would like to define here. And there is only one more block of code, the methods block. Methods, and okay. And what is important here, we define those methods as an abstract, and the abstract class may have not only the abstract methods, but if it have even one abstract method, it is considered as an abstract class. Okay, it will be important in a when we will create the real classes, but I will show you later. Okay, so the attribute abstract. Okay, and what I'm doing here is not defining the functions, but only to tell MATLAB the name of those functions, and the definition of those will be in the real classes. So for example, we will here introduce two functions, self intro, where we only want the object to introduce itself. Okay, just for representation purposes. And the second function is to compute the salary supplement for a particular object. Okay, so that's all in this class definition. What you should notice is that there is no constructor here. Why? Because there is no situation where the object of class employee will be occur in a real life. What I mean is, you cannot meet in your company the employee which is not in some subclass, which is not a driver, not an engineer, not an administration worker, but the employee itself. It cannot happen. In this manner, the employee is an abstract class, and that's why we have no constructor in here. Okay, so now let me create another class definition, I mean the real class engineer. Okay, so real class def, okay, and the name of the class engineer, and it needs to inherit, this is the operator of inheritance, after the employee class. Okay, and now properties. Okay, and we have same properties as here. Okay, but not but not only, but we have also another one property. So I can copy from here to here, paste it, okay, and I have name, surname, basic salary, years of experience. Those are same properties, but I also can define additional, which is tech field, for example. I mean the technical field when the particular engineer work on. Okay. So that's all for properties in this example. Now the methods. Methods block. Okay, without any attribute for this example. So we have a public, and it's public by default. And first method I need to create is a constructor, because this is a real class engineer which will occur in our main code as an object. So the constructor is needed here. So I use the keyword function, okay, and then this engineer, okay, class name engineer, okay, and what will be the input in the constructor? Name, surname. Those names of these inputs and those fields don't need to be the same. So I will show you this by using different names. Surname, for example, basic salary, and year of exp, okay, and for example one more tech spats, okay. So now let me fulfill the constructor with the assignment of those values to those fields. Okay, so in this particular example, that's all what I would like to do in a constructor. So let me define another function, and it will be first of our two functions which are defined as an abstract in our main class employee. Okay, so function, here is the definition, there was only the declaration. Okay, so function, the name is self intro. Okay, the function does not return anything, and it takes the object of this object of this particular real class engineer, so the engineer. Okay, and for now we would like our engineer to introduce himself. So for example, just display, and then horse cat is to concatenate horizontally two strings or more strings. Okay, so I'm an engineer. Okay, it must be a string. Okay, I'm an engineer. Then, for example, my name is, and then I would like to use the name of this engineer, so the engineer dot name, I refer to this field here. Okay, and then just let me go to another line. Those 3 dots are to go to another line. Okay, and now I need another string, which is my field of work is. Okay, and here the engineer, dot tech field. Okay, so it's that simple, just an introduction. Okay, and let me define the last one function in this particular class definition. So the function which will compute the salary supplement function, then it will return the value of the salary supplement. Okay, so comp add. Okay, the engineer, same as before. Okay, and the definition of the function. So to do not waste your time, I just copy and paste this definition and I will explain it. Okay, so what is done here? So I take from the engineer, from engineer multiplication. Okay, so this is the private variable which is defined in here as a private variable in here. So this class engineer inherits from the employee class, and that's why it can use the private variable in the class employee. So it have access to this structure here. Okay, and this structure have the fields which are like this, defined like this, with this specialization names: IT, civil engineering, electrical engineering. Okay, and so here from this structure I would like to take the field which is a tech field, and tech field of my engineer will be, for example, IT. So here there will be a IT field. Okay, and on a field which is called IT, I have the value of multiplier which is 0.03. Okay, 3%. So it will be a 3% in here. Okay, and those 3% which are taken from this structure will be multiplied by the years of experience of our engineer. For example, if the IT engineer have 5 years of experience in our company, so his addition will be 3% times 5 means 15% times the basic salary, which are here. Okay, so that's the procedure of computing the salary supplement, and as you can see, the flexibility is on the 2 levels, because we can do it differently for different kinds of our employees, which I will show you later when I define the same real class for administration worker. And we have also this internal flexibility, because we can have a different kind of engineers, and we can use this private data here to have different fields of specialization and the different multipliers for computing the salary supplement. Okay, so that's the point here. Okay, so this is all for our second real first real class definition. And now the last one file. So to do not waste your time, I just copy and paste the part of code and make only the changes. So next real class. Okay, comments are always useful. So I copy and paste the code. Maybe I can show you all of the code. Yeah, nice. So as you can see here, we have the admin class for administration worker, which also inherit after the employee class. They have the same for properties, and also some additional property specific I called whatever. So the constructor, similar thing, because the administration worker is also the real worker, which each instance of it will occur in our main code. Okay, so the constructor, very similar. Okay, and now we have similar function to introduce the admin worker. It's just a very similar introduction, but for the administration worker. So I'm the administration worker, my name is, my current position is. Okay, very similar but different. Okay, and now the other function to compute, how to compute the salary supplement for our administration worker. And as you can see, we have different procedure for doing it. For example, we decide to not taking into account the years of experience of our administration worker, but only the current position. So the administration worker position tab, and then multiply the multiplier by the basic salary. And this is also same mechanism that the admin class can use the private property of the employee class, which is just a second structure here. And this structure contains the positions which our administration workers can have. So we also have this two levels of flexibility. Okay, and that's all of our code. Just make it a bit more compact. Okay, I'm sorry. Okay, so very simple code. What I need to do is just to save it with proper names. So the proper names are the names of the classes. So I just save it to, okay, save employee. Okay, then save the engineer class, save, and then save the admin class, save. Okay, as you can see here, I have my my files, so admin, employee, and engineer. Those are the symbols of the classes files. Okay, and what I need to do now, I would like to create a very simple code for a test. Okay, so and now I create the 3 instances of our real class, so 2 instances of engineer. Okay, so for example, A1 assign an engineer. Okay, and what are the arguments of the constructor? Let me see. So name, surname, basic salary, years of experience, and tech field. Okay, so for example, name will be Adam. Okay, Jones. Basic salary, for example, 6,000, years of experience 10, and IT field of experience. Okay. Oh, I'm sorry, that's a typing mistake. Okay. And for example, A2 engineer. Okay. John. Smith. Basic salary, let's say 5,000. 3 years of experience, and for example the technical field of electrical engineering. Okay. And let's create also the administration worker. A1 admin. Okay. And for example the name Emma. Williams. Okay. For example 7,000 of basic salary, 12 years of experience, and the position of project manager. Okay. So that's all of our definition. So I'm starting this code, and I make some mistake. Okay, so my mistake was because of the change of the version of MATLAB I work on currently. So in the earlier versions of MATLAB, this kind of redefinition I made was possible, but now it's not, and I think it's better. It's good change because we just don't need to redefine those fields in here to use it after all, because we have it already defined here in a superclass employee. So in the earlier versions we have this possibility to redefine it using exactly the same names, but here we cannot, and it's actually okay because it's just not necessary because those fields are inherited from the employee class. Okay, so which are here. So I just comment out those unnecessary definitions which are here in a subclass engineer and also in a subclass admin to get rid of this error I've made. Okay, so let me show you how that's work now. Okay, so we have those 3 objects, 1 object of class admin and 2 objects of class engineer. Okay, so let's introduce our objects. For example, A1 self intro. Okay, so I just call the function self intro for my object admin class. Okay, so I'm an administration worker, my name is Emma, my current position is project manager. Okay, and for example now let's call the same function for the E1 object. So we have I'm an engineer, my name is Adam, my field of experience is IT. Okay, I just forgot the space here, not important. Okay, so now let's check how the computing of a salary supplement works for those 2 different real classes. So let's call the a1.comp add. Okay. Oh, I'm sorry. Comp add. Okay, just the typing mistake. And we have the answer is 2100, and it is correct with this procedure that this is project manager position, which is in a employee class in a private variable defined as 30%, and in admin class we defined this procedure of computing the salary supplement as the position multiplier times basic salary, which in a case of our A1 object, Mrs. Emma, it's 7,000. So it's correct, 2,100 salary supplement. Okay, so let's call the same function for A1. So for engineer Adam, which has 6,000 of basic salary and 10 years of experience and the IT field of work. So it's $1,800, and this is 10 years of experience times defined here the multiplier of 0.033% times 10 is 30%, 30% times the basic salary of 6,000, it's 1,080, so it's okay, correct. And the last one test, it's E2, and so we have 300, because this is 5,000 times 2%, which is defined in here, okay, times 3 years of experience. So 2% of it is 100 times 3 years of experience, and it is 300. Okay, so now you can see the correctness of the work of this code and how it can be flexible and useful if you need to deal with such situations. So making a same procedure for a different subclasses. So you can create the abstract class to collect all your subclasses for which the same procedure will be performed, and then define how to perform this procedure for each subclass, which are the member of those upper superclass, mean abstract class. So that's the polymorphism, that's how to code it and how to deal with it. Okay, I hope you find it useful, and if so, please give a comment, give a thumbs up, and give a sub, of course. And I would like to provide you more content about the object-oriented programming, about numerical computations as well. So see you soon, and thanks for your time.